Hola a todos, ¿qué tal? Gracias por estar ahí. Bienvenidos a esta transmisión que es la primera del ciclo de conversatorios en el marco de la celebración de los 10 años. Hoy cumplimos 10 años en nuestro laboratorio y tenemos la suerte de poder contar con Mike Begon como primer presentador en este conversatorio, donde va a tratar el tema de la importancia de la ecología de enfermedades. Para esto estaremos con Mike. Primero quería contarles que estos conversatorios van a ser todos los miércoles. Hoy es a las 14 por razones horarias, la diferencia horaria con Gran Bretaña, pero en el futuro va a ser a partir de las 18 todos los miércoles de septiembre y de octubre. Estén atentos también a otros eventos que estamos lanzando para celebrar los 10 años, que son un poco noticias sobre lo que hemos hecho, los logros que hemos tenido, y entrevistas en este mismo canal de YouTube. Y ahora voy a presentar a Mike. Bueno, Mike ha sido mi director en mi tesis doctoral. Yo fui uno de sus casi 40 doctorandos que estuvieron en lograr ser doctores bajo su dirección. Tiene una vasta trayectoria. Muchos de ustedes lo conocerán porque es autor del libro de ecología que más se ha utilizado en la enseñanza en facultades de biología de todo el mundo. Tiene más de 300 artículos científicos publicados. Es realmente un honor contar con él. Nos va a contar, calculo, algo de su historia. Hello, Mike. Thanks.
Hi, Pablo.
It's
Hi.
great to have you. Well, we met with Mike like in 2004 after exchanging some emails, because I was very interested in joining his group, which was at the vanguard internationally in the study of wildlife diseases and epidemiology in wildlife diseases. This is ecology. So thanks, Mike, for being here for this anniversary.
It's my pleasure.
So just before we start with your talk, I don't know, we would like to ask you, how about your what is your take of this career of yours that you have built so successfully?
Well, the talk that I'm going to give, the perspective I've chosen is a personal one, and it will follow my own career in many ways. So I moved from other areas of, as you will see in the talk, I moved from other areas of ecology into disease ecology. And then within disease ecology, I moved from insects, which I had worked on for 20 or 30 years, to rodents, and therefore to very different perspectives, zoonotic diseases. So my talk will exactly trace this path and try to draw some lessons that I have at least gained from these as I've walked that journey.
Excellent. So we can get started then.
Okay.
Let's
good.
see if I can share your screen.
Yeah. I can see it. Maybe
a bit blurry.
A bit blurry, yeah.
Let's hope it will get better. Okay.
Does that look okay to you?
You can start.
I can see it. It looks a bit blurry to me, but I can, if it looks fine to you, I can just talk to it.
Yeah, go ahead, Mike.
Okay.
Go ahead.
Okay, so Pablo invited me big disease. But so if we move to the next slide. Good. Okay. So, I mean, this is from a British online newspaper, really to make the point that many of us, perhaps me more than most, have worked in this area for some time, but what's happening at the moment with the COVID pandemic means that it has never been a more greatly understood area. People, journalists become experts, certainly become interested in disease ecology, begin to use terms, herd immunity, the R number and so on, that used to be our private language. And now all of a sudden, everybody is saying these things. So this perhaps has become a more relevant talk than at any other time in my career to be talking to you in this way. And if we look at the next slide, we see what I plan to do here. It's slightly difficult for me. It's so blurred that I can't quite read it. But anyway, as I've explained, I'm planning really to take you through aspects of my career and really highlight a number of things. So I'll begin, as you'll see, with some direct effects on society, things that are important to society, direct effects on pests, some direct effects on humans. I'll try to touch on the importance of drawing parallels between the systems that we work on as disease ecologists and other systems, perhaps medical, perhaps veterinary. And towards the end, I will address society in a more direct way by looking at the importance of interdisciplinary studies. So if we go to the next slide. Next slide. Okay. So this takes us back to the 1980s, which was the period in which I made the transition from other aspects of ecology, life history ecology, into disease ecology. And I did it very consciously because I wanted to be working in an area of ecology where I thought there was some importance, some significance to a wider society. I wanted an area that was both pure and applied, where there were challenges in the fundamentals of ecology, but also the possibilities of making advances that would have some benefit to a wider society. And I've lost the.
Yes, I will try something different so we can get maybe a better, not so blurry image. So let me try, because it worked before. We tried this.
Okay.
So,
yeah, that looks good.
You see? Yeah.
Yeah, I can see that fine. Yeah.
Okay.
Yeah, carry on. Okay. So at that time in the 1980s, I had switched to working with, sure, there was effectively pest control. The moth there, Clovia, is go on. That's fine. We're fine with that one. But I'd also, I think, if you could go back, just go back one. Okay. I think I'd like to make a point at this stage that I think by the time I moved into disease ecology, even with insects, two things became important to me. One was that of all subjects, it was a fantastic meeting ground for scientific interdisciplinarity. It allowed me to combine microbiology, ecology, evolution, statistics, mathematical modeling, all within one subject. And we were able to make some, I hope, good advances, both in the fundamentals of ecology, but also in aspects of pest control. And then by a kind of a strange coincidence, which I can talk about, but I won't bother with now, in the 1990s, I made another switch. If we look at the next slide. And the switch was to remain within disease ecology, but to switch away from insects to wild rodents. And it was a switch, therefore, from laboratory populations, and this is very important, I think, to wild populations, certainly very important to me, and to an even broadening of the interdisciplinarity that I was working with. All of a sudden, I was working with medics and immunologists and virologists. I could be working on statistical analysis one day, working on virology the next day. It was kind of a wonderful meeting ground. Here was the field site. If hopefully most of you will recognize Great Britain there, with Kielder Forest kind of right in the middle of it. The next slide, or the next click, will show you the kind of habitat that we worked in. These were grassy areas in an otherwise wooded environment, which meant that there were rather separate populations. And the animal we were working on, the next slide shows us, is the field vole. There we are, Microsis agrestis. And we worked in this system for many years, trying really to address two things: to look at some fundamental issues in disease ecology. If we look at the next slide, but also trying to draw out some fundamental principles that we might apply to medical and veterinary systems. But also, for the first time, I was working on zoonoses. They weren't terribly important medical zoonoses. Cowpox virus, for example, Bartonellosis, which in the UK is not very important. But there was a move to a more direct engagement with society. The next slide shows us some of the data that we collected, but I really want to make a point with this. These are 4 different populations in that Kielder Forest of field voles, and what we're looking at over, I think, about a 6-year period is the changing numbers of susceptible, infected, and recovered voles in the population. But the point I want to make with this is that these are longitudinal data. We were able to look at these dynamics because we could do in a wild animal what it's not possible to do usually in a medical or even a veterinary context, which is revisit the same animal again and again and again. Catch the animal, take a blood sample, assess their status, return them to their natural population. And these longitudinal data following the same animal over time, not just the same population, but the same animal, allows us to do many things which are not possible from cross-sectional data, and therefore not possible in, for example, a medical field where you are ethically bound to intervene even if you sample the same human many times, you must intervene if they're well. That's not the case. I'll just touch on one aspect of what we did on the next slide to illustrate the kinds of things that we did. And perhaps people won't be surprised that I've chosen to study work that really Pablo did himself. I was going to say that we did together, but this is largely Pablo's work, in which we introduced, or at least elaborated, the concept of what we called the vicious spiral. I guess many of you, through Pablo, are familiar with this, so I won't go into great details, but it explained, we found evidence within the population of ways in which small initial differences between individuals in a population could become exaggerated over time. So the small initial difference could make one individual in good condition and another in bad. The one in bad condition is then more susceptible to infection, becomes infected, gets an even worse condition, whereas the one in initially good condition remains uninfected and continues to thrive. And therefore, we see the way in which infection and other aspects of the ecology of individuals exaggerate small differences and make what might be insignificant differences profound differences between individuals. And the next slide just really puts into a phrase. Sorry, just go back one. Just puts into a phrase the parallel that we can draw. It gives us some insight into the way in which, not just in vol populations, but in all sorts of populations, including human populations, health inequalities are generated, that small differences between individuals lead to lead to disease inequalities, which lead to condition inequalities, which lead to further disease and health inequalities. That we can understand within our vol population, as others have in other natural populations, important concepts that are applicable to society generally, and certainly health inequalities are one of the major problems facing societies worldwide currently. We can understand them through the study of disease ecology. Okay, next slide then. Having worked locally, really, and on these fundamentals, in 1998, I made another transition and joined the team working on plague in Kazakhstan, bubonic plague, Yersinia pestis infection. And you can see there, in case you didn't know where Kazakhstan is and where our study site was, in the southeast there, Kazakhstan. And there is a kind of a general point to be made here that bubonic plague is something which has never gone away. Kazakhstan remains a center for bubonic plague and a medical problem there. So the next slide says, we were working really on something rather similar in many ways to the rodent system, but this time a much more important zoonosis. So I and the team I was working with were coming much closer. The interface with society in a medical sense was a much closer one. We can see something of that system on the next slide. If we have a look at the next slide, you can see the system there. The host in that area, what we're looking at is the reservoir host of plague in the area, the great gerbil. Plague is transmitted. The plague bacterium there on the right-hand side is transmitted between gerbils by fleas, and may be transmitted from gerbils to other animals, including humans, and indeed ultimately then from human to human by fleas. And the bottom right there shows the landscape. This is a desert landscape where we showed that the infection percolates across the landscape from burrow system to burrow system. I won't say so much about that, but if we do look at the next slide, you can see again that we were particularly interested in one of the fundamental concepts of epidemiology, namely that of a threshold abundance. And of course, in the COVID-19 outbreak, there has been great discussion of herd immunity, and therefore indirectly of the abundance threshold, the number or the density of susceptible individuals above which a disease will spread through a population and below which that disease will fade away. This is well known in theoretical epidemiology, but before we studied it, it had been very rarely, if ever, detected and confirmed in a natural population. And if we look at the next slide, you'll see that in applying this fundamental principle, the principle of a threshold of abundance, and the next slide, we can see that we were in fact able to detect an abundance threshold in the gerbils. And if very briefly, I just explained to you that on the left-hand side of the slide you're looking at there, you can see that the graph, the curve, is the rising and falling of the number of gerbils in that desert area. And the bars are the appearance and disappearance of plague itself in the population. And we were, the basis of what we were doing is that when there was plague in the gerbils, there was the risk of plague to humans. And therefore, if we could understand the dynamics of plague in gerbils, we could understand the dynamics of risk in humans. And we, as those slides show, we were able to detect an abundance threshold. As I say, I won't go into details, but able to detect an abundance threshold. And indeed, it was a predictive threshold. We could see when plague was coming. When the numbers of gerbils went up, the prediction was plague would appear 2 years later. And by having that predictive threshold, applying one of the fundamental principles of epidemiology, we could have a kind of a management tool to help us try to prevent outbreaks of plague in Kazakhstan and indeed elsewhere where there were naturally fluctuating populations of rodents. If we go to the next slide, then we'll see that my next and in a sense final step, but not altogether final step, I suppose, was to remain then, having moved closer to a direct effect on society, a direct medical effect. I was able to join a team working on a different disease in a different rodent in a different part of the world, but much closer to what I guess is the home of most of the people that are looking in here. So this was working on leptospirosis in the urban slums of Brazil, and I'm sure in this case there are parallels. I know that there are parallels with similar problems encountered in Argentina and elsewhere in South America. Next slide. I guess I'm only telling people what they already know here, that leptospirosis is very much a disease of poverty. It occurs throughout the world, but it is particularly an exemplar, an example of the many diseases that are particularly associated with poverty and therefore having an effect directly on society. It's a bacterial disease caused by bacteria in the genus Leptospira. There are pathogenic, but also non-pathogenic. But of course, we're interested in the pathogenic species. And the reservoir in urban environments throughout many parts of the world is the brown rat. There are other reservoir hosts as well, but in urban environments, the brown rat is the commonest reservoir, and certainly the reservoir that we have been working on. Next slide. It's a neglected disease. It's so neglected that it's not even in the official list of neglected diseases. But really, it is very important. You can see its worldwide distribution, and the estimated 80,000 deaths. So, okay, it's not malaria, it's not HIV/AIDS, and it's not tuberculosis, but it really is a serious disease, and certainly serious in the communities that we're working in Salvador. Next slide. The system, as probably most of you know, is that it is shed in the urine of the rats, and is thus shed into the environment. And it's in Salvador and many parts of the world, these are rather environments with a lot of rainfall, therefore a lot of water, a lot of open sewage. And therefore, even if people don't come directly into contact with rat urine, almost everybody is coming into contact with water contaminated with rat urine, and therefore is vulnerable to leptospirosis. And therefore, the rates of infection are pretty high. Have a look at the next slide. You can see, again, reiterating how humans come into contact. But there is a fatality rate for the more severe forms, and many people there get the severe forms. So something like 10% of the population will have leptospirosis over any 1 year period in that environment, 10 to 20%, and a high proportion of those are seriously ill, and a number of those will be dying. So this is indeed a serious infection now. I'm not going to go into too many details, but let's just move on to the next slide. Our central idea, really continuing the theme of disease ecology and its application directly to society, is again that if just really like the gerbils, if we could understand the dynamics of leptospirosis in rats, we could understand the dynamics of risk in humans, and as with the gerbils, intervene to either control the rats or to control the rat-human interface, so that use ecology and an understanding of the natural system to interfere and to intervene in that system, and ultimately improve the health and even save lives in those human populations. The next slide. So again, zoonosis control, and next slide again. But in fact, I think over the period that I've been working, and it's now, I guess, coming close to 10 years working in this system, I think it's become increasingly apparent that the problems facing us are not necessarily scientific or disease ecology problems. We know many of the risk factors, though actually many of them are known only as correlations. And the gaps in our knowledge have more to do, really, with how those risk factors interact with one another, and how we can best work with governmental agencies and with communities to attempt to benefit the humans. So the scientific problems are, of course, important, but they are not always the most important problems facing us of all. Next slide. So more recently, therefore, and really over the last couple of years and in the next 3 years, we're involved in a new program in which we're having a much more direct interaction with society. So we're trying to understand the structure, the interactions between environmental and individual and socioeconomic determinants of risk. So ecology just takes its position alongside much more social science aspects of risk. And we're therefore having to evaluate whether governmental interventions are working and whether they are working both in a scientific and in a societal sense. And also, therefore, point number 3 there, to understand the attitudes, the knowledge and the attitudes and the practices of humans within those populations. What do they understand? How does that feed through to their attitudes and their practices? And in particular, to aim to work directly with the members of the community, in particular the youths of the community, to try and engage with them and empower them to become the engineers of the improvements in their own health and well-being. Next slide. So this is a much more direct engagement with society. So we're moving now from just drawing parallels and making suggestions to understanding that as scientists, we cannot stand apart from society. We must directly engage with society and be led by society in knowing what's the right things to be doing in particular situations. Next slide. So we see ecology, and in this case leptospirosis, as really just being part of an overall kind of Venn diagram of interacting elements, but only a part of it. And I think we're moving towards this much more interdisciplinary role in which ecology is, of course, important and remains important, but ought to be seen as embedded within this wider this wider group of the natural and social sciences, and one in which we are not simply, we don't just see this but stand in the ecology section and look out at the others, but we need to be working with the others. We need to be working with the human epidemiologists, with the social scientists in that, and with the social activities of the communities. Next slide. So we can begin to see some of the results that we're seeing by doing this. So this shows one of the communities. It's a heat map of one of the communities. But well, it's in fact it's 2 heat maps, and the way in which we are able to equate from human data on environmental degradation, where are the worst areas, even within this poor slum community, there are hotspots of environmental degradation, and you can see that they are indeed the hotspots of ill health, even within the communities, so that it is not enough for us to identify, of course, that urban slum dwellers are disadvantaged, that even within these disadvantaged communities, there are disadvantaged amongst the disadvantaged, even within those communities. And we're able to do that by combining the disciplines together. And then in the next slide, and then the next slide, let's put the next slide on again. Okay, so just one more of the ways in which we are able now to work with the social scientists. And you can see, perhaps, if we look at the 3rd point there, is time is moving on somewhat, you can see the way in which poverty, even within these communities, impinges, the poorest amongst the poor, it's not that they don't have the knowledge. They understand the risks. They know what they should do, but they are nonetheless unable, through their poverty, to act out the practices that they should be, and they are therefore something like 3 or 4 times more likely to have unsatisfactory practices. They know what they should do, but they are unable to do the right things. And as a result of that, not because poverty makes them less knowledgeable, because poverty disallows them from doing the right things, they are more likely to become infected and ultimately ill, and perhaps ultimately die. So next slide. Just to allow me to make some final observations. I said early on that one of the first things I learned when I moved all those years ago now, what is it, 30 odd, maybe almost 40 years ago into disease ecology, that all of us working on disease ecology should be so glad that we are working in an area which is such a perfect meeting point for scientific multidisciplinarity, and therefore challenging and satisfying in that regard. But insofar as it has applied aspects, I think I've increasingly become convinced that working in disease ecology invites us to an even broader interdisciplinarity with the social sciences, with the political sciences, and with the people that we are aiming to help, working directly with them. But I suppose my final comment would be that interdisciplinarity, of course, everybody believes it's a good thing. Everybody will say that it's a good thing. But it's never easy. You need to choose your teams carefully. An interdisciplinary team is not a team of specialists who just all sit together in the same project. It needs to be a team of specialists, each one of which makes it their business to understand what the others are doing. So we as disease ecologists must be open to try and understand what the social scientists are doing. If you choose to work in an interdisciplinary team, choose your social scientist well, choose one that wants to understand the science on their part, and then I think we will perhaps see the best harvest of applying disease ecology to doing something genuinely helpful in society. And if we just go to the last slide, it just allows me to say thank you so much. Thank you to Pablo, and thank you to anybody who happens to be listening. It's rather a strange experience to be talking to this screen and not knowing if there's even anybody out there. But anyway, thank you if you've listened to this. I hope it's been clear. And here, Pablo, it's to the next 10 years and even to the 10 years after that. So, a happy birthday to your lab.
Thanks a lot. Thank you, Mike. That was a phenomenal talk and a great message, and certainly the way to move forward, connecting the knowledge we are trying to generate with and reaching society with that, and working as a team. That's really a challenge, but we need to look forward to that, to try and engage in that. We have some questions. I don't know if some of them are in Spanish, some of them in English. Eduardo Tramper asks if, when you were talking about the vicious spirals, if there have been development of models with compartments where you have people with poor condition and people in good condition.
if there are, I'm not aware of work in that way. I mean, I think it's an important area. I mean, it's something. Pablo, probably you're the better. I mean, I think in any of these cases, you may be the best person. I know. I mean, Pablo perhaps won't say himself. I know that he has been thinking, even in terms of the COVID situation, whether it may have some relevance in that situation, and I think it may. And I think there is an area for modelling picking up on this in human populations. Such models may exist, but if they do, I'm not aware of them. But that could simply be my ignorance, and Pablo may have another answer. So I mean, I think that would be true in a medical context, but especially perhaps in the veterinary context as well, where I think you've given some thought to this, Pablo. So I don't know if you want to comment as well. And you can comment in Spanish if you prefer, of course. But,
Yeah, in fact, we are collaborating with people from Liverpool and elsewhere in Britain now, trying to develop models a bit similar to that, with compartments of different infectiousness in this case. So yeah, it's things that needs some work, good ideas that need to be looked at. The program could be applied at this time. I think Patricia Marconi, means the program you were talking about, the leptospirosis.
yes.
And perhaps the relevance to COVID. Eduardo Trampa has no other questions. Given the importance of space and movement of the members of a host population, what do you think about the agent-based models, if they could be a better option?
Well, I think agent-based models are always a better option in the sense that they are closer to reality. I think with all modeling, there are decisions to be made as to whether you go for very general models in which the population is homogeneous, there is no explicit use of space and so on. And of course, such models have a role in uncovering easy to see general principles. But the closer you come to wanting to make, for example, or to give advice to governments, of course, you need at the very least to move closer to agent-based models. The problem with agent-based models is that you may demand data that is simply not available. So I think every modeler and everybody involved in incorporating modeling into this or into any other study needs to strike the right balance, needs to decide what it is that they want to do and how they can best, how they can use a model that on the one hand seems to reflect the realities of the system, but on the other hand is not so hungry for data that don't exist.
Mm-hmm.
That you end up saying, well, this might be the case, but we don't know. And so I think wherever possible, wherever there are data for agent-based models, that they are valuable. And indeed, agent-based models can give us insights, of course, because they can allow us to introduce heterogeneities that population models cannot. But basically, I think each of them has their role. That I think in every study system, there are roles for the rather broad models and also roles for the more detail-specific, such as agent-based models.
Mm-hmm. Other question is if for the leptospirosis experience, there was use of companion modeling. Are you familiar with companion modeling? Or
I'm afraid I don't know what companion modeling is. I'm sorry.
Me neither. And another question is if the models developed contributed to improve the prevention and management of diseases that were studied.
I think okay, so the answer to that question, I would say, is that the models have always been disappointing. This is one reason, I think, why the team and I personally have moved closer to direct interaction with residents, with communities. I think I have been part of a tendency for scientists to address a problem, develop a model, make a prediction, make a recommendation without enough thought to whether that would be an acceptable or a practical recommendation and so on. And I think if you ask me whether the models have been useful, the answer is not as useful as we hoped they would be. And I think the reason is not necessarily that the models were bad, but that they were developed too much in isolation from the people who would have to implement those models. And so the lesson I learned from that really is not necessarily to make better models, but to make models more closely in collaboration with the from the outset, more closely in collaboration with the people who will have to be part of the implementation of them.
Exactly. Andrea Previtali asks, how should undergraduates or graduate students be better prepared to work in interdisciplinary teams?
Well, first of all, hi, Andrea. Nice to hear from you, even through an intermediary. Very nice to be in touch with you indirectly. Well, I think one way in which we can do this is almost to make, we perhaps almost have to make interdisciplinary case studies a kind of a recurring theme in undergraduate syllabuses. I think we can't expect our undergraduates necessarily to be, on a Monday doing a course in virology, and on a Tuesday be doing a course in social science or political science. So I think there are limits, but I think if we believe, those of us who believe in interdisciplinarity, I think simply need to be getting that message across. Perhaps there is some opportunity for courses almost on interdisciplinarity, on the way in which these things can work. But I think really, if we believe it, then we almost have to be sending that message. I think case studies are perhaps the most obvious way in which we can do it. Simply get that message across, and not to tell our undergraduates that I think Britain is particularly bad here in the UK in making people specialise too soon. Maybe you do a better job anyway in Argentina in giving a broad education. But I think if it can be done at the undergraduate level, then that's great. We don't do it here. Maybe you're already doing a better job than we are, but I think the first step, of course, is to want to do it, is to make it a mission of our education to impress upon scientists that they are part of society and must understand society as well as understanding their science.
Good. Another question from Ana Paula Cutrera. She's asking whether the inequality in the access to health and proper housing could impact the vicious circle and how that could translate to the COVID pandemic.
Well, I think it does. I mean, I think we see these kind of vicious circles even within the slum communities. I mean, I think it's possible to see just big. I mean, and probably people there, people listening, probably have at least as much experience and direct experience of this as I do. One can, as soon as one recognizes the concept of the vicious circle, the vicious spiral, one can go into communities and see it happening. One can see that those, you know, with the greatest health problems are in many cases, I mean, they may simply, as a result of their health problem, they may be unable to work. As a result of being unable to work, they're even poorer than their neighbor. And so one sees this all the time. I'm sure it must be true in COVID. I guess, well, and we know that it is true here in the United Kingdom. So, I mean, I just give an example. Probably you have better ones there, but let me just give you one example here in the United Kingdom. The poorest people here are the ones who have been forced by their employers to carry on working, even though that brings them into contact with others. And so there have been outbreaks here at times when we were being quite successful as a country in holding back COVID. The outbreaks that were occurring were in many cases happening in factories where the poorest workers were being forced by the factory owners into continuing to work, and they could not afford not to work, and so they worked and were more likely therefore to be the ones getting COVID. And of course we know that that many of the comorbidities, many of the risk factors associated with COVID are diseases of poverty, poor diet and so on, poor general condition, high blood pressure, untreated high blood pressure, untreated diabetes, all things that are more likely to occur in the poorer parts of society and in particular ethnic groups as well. So I think we do see these things playing out all the time. I mean, I think it is a very, very general phenomenon that we see playing out all the time in society.
Good. Pilar Fernandez, she made a question. It's in English. I don't know if you're reading.
No,
how can we better address the ubiquity of systems to make better recommendations and better understand the system behavior? Do you have any good examples of studies that have succeeded on this?
Well, I have some. The first thing I should say is I don't pretend to be an expert on this. I am something of a new convert. But I think our experience in Salvador is that there is much to be gained by directly, as I said in my talk, interacting with the youth in society. So I think the youth have energy, they have enthusiasm, they are the future. And I think as well that they can be very persuasive. So one example, and I take no credit, this is the team working, this is the Brazilian team working in Salvador. Working with the youth, we're able to infuse them. The youth then managed to get an audience with the state governors, the legislators in Salvador, And because it was the youth that made a presentation to the government there in Salvador, the local law has been changed as a direct result of the interaction. They were so impressed that the youth from the favelas, from the slums, were engaged with this. And so I think the way to make changes is to work with the local communities and perhaps with key parts of the local communities. And I think the combined weight of scientists with local residents can be more persuasive in making change than either scientists on their own or the local residents on their own. So I think working with them, our experience at least is key.
Excellent. Well, many people saying thanks, congratulations, etc. We had like always over 100, sometimes 140. So good audience, and this can be accessed anytime because
Sure.
it will be on the YouTube channel. So for anyone who missed it. So thanks a lot again, Mike.
Okay. You're very welcome. You're very welcome. I mean, I wish you well for the rest of this meeting. I mean, I don't know who's listening, but hello to anybody who knows me. I hope this has been of some use anyway, but more than anything else, I mean, because of course our labs know one another quite well. So, you know, my congratulations on 10 years, but my congratulations as well on the work that you guys are doing. I mean, if your time in Liverpool played some part in that, then I'm very pleased and very proud of what the outcome has been for your work there in Santa Fe. So it's great to see you. Enjoy the rest of the meeting.
Okay.
Everybody can relax and start speaking Spanish.
Yeah. Bueno, muchas gracias.
Okay.
Hasta luego.
Bye, guys.